Morning to all. Myself, Dr. Kalaichelvi, Professor of Religious Department, Fundamental Fellowship. And today we are going to talk about the topic of functional dependency. So, what is this functional dependency? This functional dependency is a constraint that describes the relationship between attributes in a relation. This functional dependency and these are used to define the normal forms of relations. So, these functional dependencies play a major role in the databases. There is this functional dependencies is one of the major constraints which makes the table normalized state. Okay, is it necessary to make a table as a normalized state? Yes. Let's know what's the importance of normalization of the table. Once we make a table as a normalized state, the normal kind of activities like insertion, deletions, and all kind of database transactions will be effective. To make a process of your database transactions in efficient way, we must make a table in a normal state. That is why the process of normalization will reflect in database applications. So to make a consistent table of a database, consistent state of databases, we need to have a normalization. To provide the normalization state, we need an important property that is called functional dependencies. So here the functional dependencies play a major role to make a normalized state of a table to give a consistent state of the relations. Functional dependency is a property of attributes in a relation schema where if L is the key of a relation R, it determines all the attributes of the relation R. Now, the functional dependency is a foundational concept in database normalization, which is used to analyze, identify, and eliminate the data redundancies and anomalies by establishing the relationship between the attributes that is X tends to Y. Now, what kind of different functional normal forms are there? This functional dependencies defines the keys which helps to identify partial dependencies in second normal form, transfer dependencies in third normal form, and multivalent dependencies in fourth normal form, ensuring each attribute depends only on the primary key. Now, the functional dependencies allow the designers to break down the tables into very simple and small tables, which are related tables to achieve a specific normal forms like 2NF, 3NF, and BCNF. When the table is very high, it is very tough to process the transactions. If you are able to break down the tables in a simplified form, the transaction is very simple and easier. So breaking down the large and complex tables into smaller and simpler tables through the process for normalization. To achieve a normalization, we need the main property called functional dependencies. So the normalizations eliminates the duplications of the redundancy, which prevents updation, deletion, and insertion anomalies, and which also ensures the data integrity of the databases. This normalization helps the databases organizes data logically, and mainly this function dependencies on normalization, which reduces the unwanted storage, and it improves the query performance by minimizing the duplicated and unnecessary information. What are the key components which is used for this functional dependencies? That is, we are going to represent this functional dependencies as X tends to Y. We can read as X functionally determines the value of Y. Or we can say Y is a functionally dependent on X. That is, the LHS is X determinant. The attribute or set of attributes used to identify the values uniquely. RHS component. Y is a dependent variable. The attribute whose value depends on the determinant, that is called dependent variable. And the composite dependencies. Multiple attributes on either side or separated by commas. For example, A, comma B tends to C. So C depends on both A and B. Like for example, we have a student table where we have a dependencies like from student ID to student name. It means student name can be offered from the value of the attribute student ID. Similarly, we have employee table. We can derive the value of the attribute like salary and employee name from an attribute value employee ID. From an employee ID, we can derive two different values of the attributes. So employee name and salary derive depends on the left attribute determinant employee ID. This is a simple example which depicts the relations between the student and the relation called sport. So here we have a student relations where we have a attributes like student ID, student name, and birth date. And we have another relation called sport where we have different kind of sports name and the type of sports it belongs to. So it is playing a many to one relationship, which plays student play a different sports relationship. Okay, so from this what we can derive from student ID, we can derive the values of the student name as well as birth date. Also from student ID, we can derive what kind of sport name he belongs to, how many hours he's playing a particular sport. So like this kind of information we can collect from the help of the functional dependencies. Function dependencies is used for the some constraints. That's what we say. For example, sport name determines a type of sport. If we have a sport name, we can able to have the type of a sport he belongs to. And we suppose we want to calculate how many hours he spent for the particular sports. If we have student ID and sport name, we calculate the total number of hours he spent for the week to practice. Like to process this functional dependency, we use some of the inference rules. Let us see what the different inference rules are there. Here we generally call it Armstrong's inference rules. The first one, reflexive rule. That is, if y is a subset of x, then we can write x tends to y. Another rule, augmentation rule. If x tends to y, then we can also write xz tends to yz. That is, if the value of x is there, if we want to derive the value of y, we can derive the value of y from z, x. We can also derive xz to yz. It means xz stands for x union z. The next property, transitive property. If x tends to y and y tends to z, then we can also derive from x to z. Instead of your skipping y, we can directly derive the value of z from x. Since we have the property x tends to y and from y, we derive the value of a z. So that is what the transitive property. We directly get the value of a z from x since the value of y derived from x. What's additional rules for the inference? We have a decomposition, union, and pseudo-transitivity. Decomposition. If x tends to y z, then we can decompose into two. That is x tends to y and x tends to z. In determinant, we have one variable. In dependent variable, we have two variables. Then we can split into two function dependencies. And the union, if we have two different function dependencies, we can combine. If x tends to y and x tends to z is available, then we can combine into one FD, that is x tends to y z. Then we have another property called pseudo-transitivity. If x tends to y and wy tends to z, then we can have transitive property wx tends to z. The value of y derived from x, then we can replace the next functional dependency. In case of x, we can replace wy to z. So y is from x. So that's why the second property, the final property we can derive wx to z. Okay, that's all about the different Armstrong rules. Now let us see the different types of functional dependencies we have. We have trivial functional dependencies, non-trivial functional dependencies, multivariate functional dependencies, and transitivity dependencies. That is the one in short, trivial functional dependencies. And functional dependencies is trivial if the right hand side is a subset of the left hand side. That's a rule. If it is a trivial, it's sure that the right hand side dependent variable is the subset of the left hand side variable. AB tends to B, that is A tends to A, B tends to B. It means the attribute already exists in the determinant. Non-trivial functional dependencies. If Y is not a subset of X, then it's that X tends to Y is non-trivial. Example, if student ID is there, from student ID, we can derive a student name. But in case name is not a part of a student ID, then multivariate functional dependencies. If one attribute determines multiple independent values, it is an multivariate functional dependencies. For example, we take a relation of bike where we have a bike model, manufacturing year, and color. Now we have the functional dependencies. From the bike model, we can derive the value of the manufacturing year. Also, we have another functional dependencies. From the bike model, we can also derive the variable called color of the car. So like we have a multiple value can able to derive from this kind of functional multivariate functional differences. This manufacturing year and color are independent. This leads to an fourth normal form, transitive dependency. A dependency is transitive if it is indirectly formed. For example, X tends to Y. From Y, Z can be derived. Then Y does not belongs to X. It means we can form a relation X tends to Z. Example, from department student ID, we can derive the value of the department ID. As well, from department ID, we can get the value of department name. Okay, from student ID, we can also derive department. In turn, student ID, we can derive the value of the department name. So indirectly, we can get the value of the department name from student ID. That is only with the 3 or more attributes, which is removed using third normal form. Finally, the last topic of functional dependency is the closure of functional dependency. Database management system, the closure of a set of attributes, that is X plus X closure, the set of all attributes that can be functionally determined from X using a given set of function dependencies. This concept is crucial for finding the candidate keys and super keys for the normalization. The idea behind the closure property of X is the function dependency. If X tends to Y is a function dependency and X is the closure set, then Y can also be added to the closure. This is simply we can use the function dependency used for the closure of the function dependency. Thank you. So this is what we are going to complete the session of the functional dependency importance in the database systems. Thank you.